Hello, I am Danial Haiqal from Group 2. Will be presenting about trickling filters. So this group is consist of Fizri, Azim, myself, Amira, Aainaa, and also Raihan. So next slide. So for the introduction, uh, there what is actually a trickling filter? A trickling filter. So a trickling filter is actually a type of wastewater treatment system. It is used in phase 2. It actually consists of a fixed bed of rocks. Coke is actually porous fuel that is gray and hard. Gravel is actually a rock fragments. Slag is actually a mixture of metal oxides and silicon dioxides. Polyethylene foam, sphagnum peat moss, which actually used to grow mediums or media, ceramic or plastic media. So it actually enables organic materials to be absorbed by a population of microorganisms. Next slide. So these are the essentials needed for a complete trickling filter. So the first one would be a medium or a filter bed that has a microbial slime that actually developed. Second would be a place that is enclosed or a container which keeps the filter bed. The third one, it actually needs a system that distributes the flow of wastewater over the filter medium. And lastly is that we need a system that actually removes the sludge and dispose of any sludge that and uh, any sludge from the treated effluent. So next one I'll be explaining on how it works. As the wastewater flows over the medium, microorganisms already in the water gradually attach themselves to the rock, slag, or plastic surface and form a film. So this film is actually called biofilm. The organic material is then degraded by the aerobic microorganisms in the outer part of the slime layer. Um, as the layer thickens through the microbial growth, oxygen cannot penetrate the medium phase, and anaerobic organisms develop. And as the biological film continues to grow, the microorganisms near the surface lose their ability to cling to the medium, and a portion of the slime falls off the filter. This process is known as sloughing. The slough solids are picked up by the underdrain system and transported to a clarifier for removal from the wastewater.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Fizri Hazeem bin Ismail, and I'll be explaining about the parameters involved. Okay, for the calculation part, there are basically 4 things that we need to calculate, which are hydraulic loading rate, organic loading rate, BOD and SS removal, and lastly, recirculation ratio. Okay, we will start with hydraulic loading rate. Calculating the hydraulic loading rate is important to account for both the primary effluent as well as the recirculated trickling filter effluent. Effluent means the sewage discharged into a river or the sea. So we basically just want to know how much effluent from primary and the recirculated one is being discharged into the river. These quantities are combined before being applied to the filter surface. So the formula is hydraulic loading rate, which in this slide as in GPD over feet square. GPD is gallon per day, equal to total flow applied in GPD divided by area in feet square. So to find area, just use the area of circle given, which is equal to pi r squared, and the flow rate need to be added, F1 plus F2, dividing the total flow rate with area, and we will get the hydraulic loading rate that is desired. Okay, moving on to organic loading rate. The organic loading rate is expressed as the amount of BOD, which means foods applied to a certain volume of media. It is basically a measure of the amount of food being applied to the filter slime. To calculate the organic loading on the trickling filter, 2 things must be known. First, the organic load, And the second one is the volume. To find organic load, concentration needs to be times by flow, and to find volume, we need to times the area with depth. And so, after we get the value, organic load, which is in the unit of pound BOD per day, will be divided by volume 1000 feet cube. Note that the 1000 feet cube is just a unit. And so, the organic loading rate will has the unit of pound BOD 5 per day per 1000 feet cube. Okay, next we will move on how to calculate BOD and suspended solid removal. Okay, in order to determine the amount of BOD and suspended solid removed by a trickling filter, you must know the BOD and suspended solid removed as well as the plant flow rate. The BOD unit is normally in mg per liter. Okay, how to calculate BOD remove? Normally, we will be given two readings of BOD, BOD1 and BOD2. And from there, we will get the BOD remove. Okay, after we have get the BOD remove, use the equation given here, which is concentration in mg per liter that we have just calculated just now, times with flow in mgd times 8.34 pound per gallon. From there, we will gain 2802.24 pound per day. So from the concentration just now, we just want to convert it into pound. Okay, for the recirculation ratio, it can level flow variations and assist in solving operational problem. It is needed to check rate of recirculation to ensure that it is within design specification. The trickling filter recirculation ratio is the ratio of the recirculated filter flow to the primary effluent flow. Normally, both of this value, the recirculated flow and the primary effluent flow is given. We just need to find the recirculation ratio. So just divide it like usual. Okay, that's all from me. Thank you.
Right now, we will be explaining about the design process of trickling filter.
A typical trickling filter is circular. The size is between 10 meters and 20 meters across and between 2 meters to 3 meters deep. It consists of permeable medium made of a bed of rock, slag or plastic where the wastewater is distributed to trickle through as shown in this figure here. Rock or slag beds can be up to 60.96 meter, which is 200 feet in diameter, and 0.9 till 2.4 meters, which is 3 to 8 feet deep, with rock size varying from 2.5 until 10.2 cm, which is 1 to 4 inches. Packed plastic filters, which also known as biotowers, on the other hand, are smaller in diameter, which is 6 to 12 meters or 20 to 40 feet, and range in depth from 4.3 to 12.2 meters, which is 14 to 40 feet. Research has shown that cross-flow media may offer better flow distribution than other media, especially at low organic loads. Trickling filter has an underdrain system that collects the filtrate and solids and also serves as a source of air for the microorganisms on the filter. The perforations on the pipes are designed to allow an even flow of liquid over the whole area of the media and are also angled so that when liquid flows from the pipes, the whole assembly rotates around the central spindle. Larger filters may be rectangular and the distribution arms may be driven by hydraulic or electrical system, while the smaller one often use a tipping bucket device. There are 4 types of filter for trickling filter, which is low rate filters, intermediate rate filters, high rate filters, and roughing filters. For the first one, which is low rate filters, it is commonly used for loadings of less than 40 kilograms 5-day biochemical oxygen demand over 100 meters cubed per day. It also has fewer problems than other filters with regard to filter flies, odors, and medium plugging because of the lower loading rate. Most low-rate filters are circular with rotary distributors, but some filters currently in use are rectangular. while intermediate rate filters often loaded up to 64 kg 5-day biochemical oxygen demand over 100 meter cube per day. In order to ensure good distribution and thorough blending of the filter and secondary effluent, the system should recirculate the trickling filter effluent. The biological solids that slough from an intermediate trickling filter are not as well digested as those using a low rate filter. Next is high rate filter. It can be loaded at the maximum organic loading capabilities of the filter and receive total 5 biochemical oxygen demand loading range from 64 to 160 kg, 5 biochemical oxygen demand over 100 meter cube per day. Using this filter, achieving a secondary quality effluent is less likely to happen without second stage process. As a result, high rate filters are often used with combined processes. The last filter is roughing filters. It is designed to allow significant amount of soluble biochemical oxygen demand to bleed through the trickling filter. This type of filter generally have a design load ranging from 160 to 480 kg 5 biochemical oxygen demand over 100 meter cube per day.
So now I'm going to present about the advantages and also the disadvantages of trickling filters. First, for the advantages, first is a simple, reliable and biological process. It also rapidly reduces soluble BOD5 in applied wastewater. Next, it is very suitable in areas where large tracts of land are not available for land-intensive treatment system, so which means it's very appropriate for small to medium-sized communities. And it may qualify for equivalent secondary discharge standards. Next is also the low power requirements, as they only require power for pumping only and do not need large power as hungry aeration blowers from motor-driven rotary distribution, one powered by fractional horsepower electric motors. Next is also effective in treating high concentration of organics depending on the type of medium used. And lastly, it also moderate level of skill and technical expertise needed to manage and operate the system. So now for the disadvantages of trickling filters. First, it requires regular operator attention, and it also additional treatment may be needed to meet more stringent discharge standards. And it also can cause possible accumulation of excess biomass that cannot retain an aerobic condition and can impair TF performance. Next, it also requires low loadings depending on the mediums, meaning that only low influent that can be entered at the time. Next, also flexibility and control are limited in comparison with activated sludge process. Other than that, for trickling filters, the disadvantages is it require high maintenance costs of rotary distributor center mechanisms. So for any maintenance service for the rotary distribution mechanism, it would require a complete removal of the rotary distributor mechanism, guide rod and arms.